You've never touched anything in your entire life, not once. That feeling right now, your fingers, the chair, the floor under your feet, that's not contact. That's electromagnetic repulsion. Your hand and every surface it's ever come near have never actually met. Not at the atomic level, not even close. And that's just the beginning of how wrong our picture of matter is. Because here's where it goes. If you scale a hydrogen atom up so its nucleus is the size of a marble, a small marble sitting on the ground, the electron orbits about a kilometer away. Everything between them is empty. The atom is 99.999999% empty space by volume. You are 99.999999% empty space. But here's the thing the pop science version always stops too early. It tells you you're mostly empty and leaves you with that, as if emptiness is the answer. It isn't. Because that empty space isn't actually empty, and the solid parts aren't actually solid. Both halves of what we assumed about matter turn out to be wrong. And what's actually there, what fills the space and what makes the particles, is stranger and more beautiful than either. So let's go in, all the way in, and find out what you're actually made of. Start with the atom. Everyone's seen the diagram. Nucleus in the center, electrons orbiting around it like little planets, neat circular paths, everything tidy and mechanical. It's in every physics textbook. It's in every science classroom. And it's almost completely wrong. Electrons don't orbit. They don't have paths. An electron isn't a tiny ball moving through space on a defined trajectory. It exists as a probability cloud, a quantum wave function spread across a region of space. The electron isn't at a specific location. Before you measure it, it's genuinely smeared across a volume, more likely to be found in some places than others, but not anywhere definite. The moment you measure it, the moment you interact with it, it snaps to a location. But between measurements, asking where it is doesn't have an answer. Not because we haven't measured precisely enough, because the question doesn't have an answer. The diagram we draw is a lie we tell, because the truth is too hard to draw. The nucleus is its own story. Protons and neutrons packed together, held by the strong nuclear force, the most powerful force in nature, operating only at distances smaller than an atomic nucleus, holding things together against the electromagnetic repulsion that would otherwise blow every positive charge apart. But even protons and neutrons aren't fundamental. Zoom in further, and each one is made of 3 quarks, bound together by particles called gluons, in interactions so energetic and complex that the math, quantum chromodynamics, can barely be computed even on the best supercomputers we've ever built. So the clean little model with the orbiting dots, gone. What's actually there is a probability cloud surrounding a seething knot of quarks and gluons held together by the strongest force in the universe. And that structure is itself almost entirely empty space. Now here's the thing about mass that almost nobody knows. And I mean this. This one genuinely surprised me when I first worked through it. The quarks inside your protons and neutrons account for about 1% of the proton's mass. 1%. The rest, 99% of the mass of every proton, every neutron, every nucleus in your body, comes from somewhere else entirely. Where? From energy. From the kinetic energy of quarks moving at nearly the speed of light inside the proton. From the energy stored in the gluon field holding them together. Mass, in this case, is frozen energy. Einstein's E equals mc squared, running in reverse. Energy becoming mass. Mass being energy in a very particular arrangement. You step on a scale. It says 70 kilograms. You think that number is measuring matter. It isn't. It's measuring mostly energy. The violent, high-speed dynamics of strong force interactions happening inside every proton and neutron in every atom of your body. You are not a collection of things. You are a collection of events. Ongoing, dynamic, energetic events happening at scales so small they're almost impossible to think about. The quarks themselves, nearly massless. They get their small mass, that remaining 1%, from interacting with the Higgs field, a quantum field that permeates all of space, everywhere, at all times, giving certain particles resistance to acceleration. The Higgs boson, discovered at CERN in 2012, wasn't a new particle we found lying around. It was a ripple in that field, evidence that the field is real, that it's there, that it's doing what the math said it should be doing. Which brings me to the thing that changes the whole picture. The space inside your atoms isn't empty. It's full of quantum fields. This is the shift you need to make to understand what matter actually is. Stop picturing particles as tiny balls sitting in empty space. That's the classical picture, and it's wrong. The correct picture, the one quantum field theory gives us, is this. Space is not a container. Space is filled with fields, quantum fields, about 17 of them in the standard model, overlapping, permeating all of space, everywhere, always. The electron field, the quark field, the photon field, the Higgs field. Every type of particle corresponds to one of these fields. And a particle isn't a thing inside the field. A particle is an excitation of the field. It's what the field looks like when energy concentrates into a localized ripple. Think of the ocean. A wave isn't a separate object from the ocean. It's what the ocean does when energy moves through it in the right way. An electron is what the electron field does when it has enough energy to make a localized disturbance. Between the electrons, between the nuclei, in the vast apparent emptiness inside every atom, the fields are there, always, everywhere. The vacuum, a region with no particles, lowest possible energy state, isn't nothing. It's the quietest possible state of something very active, and we can prove it. The Casimir effect. Take two uncharged metal plates, place them extremely close together in a vacuum, and they attract each other. Why? Because virtual particle pairs, excitations that borrow energy from the vacuum for the briefest moment allowed by Heisenberg's uncertainty principle, can exist in all wavelengths outside the plates, but only in wavelengths that fit between them. More vacuum energy outside than inside. The imbalance pushes the plates together. This is not a thought experiment. This is measured. The force is measured. The vacuum pushing metal plates together with a force we can calculate and confirm. The emptiness is doing work. But if the vacuum is full of active quantum fields, if virtual particles are constantly appearing and annihilating everywhere in space, why does anything feel solid? Why doesn't your hand pass through the table? Two reasons, and the second one is the deeper one. First, electromagnetism. The electrons on the surface of your hand and the electrons on the surface of the table carry the same charge, negative. Like charges repel. As your hand gets close to a surface, the electromagnetic repulsion between electron clouds builds rapidly. That sensation of touching, of pressure, of resistance, of solidity, is the electromagnetic force pushing back. You're not making contact, you're feeling a force. But here's the deeper answer. Wolfgang Pauli, 1925. The Pauli Exclusion Principle. No two fermions, particles like electrons, can occupy the same quantum state in the same location. This isn't a force. It's not a push or a pull. It's a rule baked into the mathematics of quantum mechanics at the most fundamental level. Two electrons simply cannot be in the same place with the same quantum numbers. It's prohibited, mathematically, absolutely. This is why matter has structure. This is why atoms have complex electron configurations rather than all electrons collapsing to the lowest energy state. This is why chemistry exists. This is why DNA can form, why proteins fold, why biology happens at all. The Pauli Exclusion Principle is the reason the universe isn't a featureless lump. And it's the reason your hand doesn't pass through the table. Not because matter is solid, because electrons refuse, at the level of quantum mathematics, to share their states. The universe is held up by a prohibition. Solid isn't a property of matter. It's a consequence of a rule that matter obeys. Now, I want to go one level out, because everything I've described so far, quarks, electrons, quantum fields, the Higgs, the Pauli principle, all of the standard model, accounts for approximately 5% of the universe. 5%. The other 95% has two labels, dark matter and dark energy. Both are inferred from their effects. Neither has been directly detected. Neither has been explained. Dark matter first. Galaxies rotate wrong. Stars at the outer edges of galaxies move too fast. By Newtonian mechanics, by general relativity, they should fly off into space. They don't. Something is providing extra gravitational pull. That something doesn't interact electromagnetically. It doesn't emit light, absorb light, reflect light. It's gravitationally present and otherwise invisible. We've mapped where it is by how it bends light and affects galaxy rotation. We have no idea what it is. Every candidate particle proposed has either been ruled out or not found. Dark energy is stranger. The universe isn't just expanding, it's accelerating. Something is pushing space itself apart, overcoming gravity on the largest scales, making the expansion faster over time. That something appears to be a property of the vacuum, energy inherent to space itself, the cosmological constant. And here's the embarrassing part. Quantum field theory predicts a value for this vacuum energy. The measured value disagrees with the theoretical prediction by a factor of 10 to the power of 120. That's not a rounding error. That's the largest discrepancy between theory and experiment in the history of physics. We know it's there. We can't calculate it. We don't know what it is. The most precise scientific theory ever constructed, quantum electrodynamics, accurate to 11 decimal places, describes 5% of what exists. The label on the other 95% says unknown. So what are you, actually? You are a temporary, self-organized pattern of quantum field excitations. Your mass is mostly a frozen energy from strong force interactions. Your structure is maintained by electromagnetic repulsion and a mathematical prohibition on electron overlap. The space inside your atoms is full of quantum fields at their ground state, seething with virtual activity. You are made of atoms that are almost entirely empty, and that emptiness is the most active part. And here's the edge I want to stand at for a moment. The fields don't stop at your skin. The electron field inside you is the same field as the electron field in the air around you, in the ground under you, in the stars above you. It's one field, everywhere. The boundary between you and the rest of the universe, the thing that makes you feel like a separate object, is a pattern. A stable, self-maintaining, highly organized local excitation in a set of fields that extend across the entire cosmos. You are not in the universe. You are a temporary local feature of it, a wave that's convinced itself it's separate from the ocean. That's not mysticism. That's quantum field theory. And here's what I find most striking about all of this. The fact that fields, invisible, probabilistic, spread through all of space, governed by mathematical rules we're still working out, manage to organize themselves into something that can hold a coffee cup, that can build a telescope, that can ask questions about its own composition, trace its own mass back to quark dynamics, map its own emptiness, and sit here, genuinely astonished by what it finds. The universe organized almost nothing into something that can notice it's almost nothing. You put your hand on a table and it feels solid and real and there. And it is real. But what's doing the work isn't matter. It's mathematics, forces, rules, patterns in fields that fill all of space. You are real. You are also almost entirely empty. And the emptiness, the fields, the forces, the quantum rules holding the pattern together, that's the most interesting part. Not because emptiness is profound, because what fills it is.